All right, guys, here you go. The mean doesn't change. The sample size doesn't affect the mean at all. The formula is just the mu of p hat is just p. So they're both 0.72. Standard deviation does change, though, because you have a 100 here in the numerator instead of a 50. That makes it smaller. It was 0.0634. Now it's 0.04. The standard deviation got smaller. I went 100 times 0.72 and 100 times 0.28. I got 72 and 28. It's definitely approximately normal. So I drew a normal curve. I put 0.72 in the middle. I put 0.65 over here. It looks like the same drawing with the same thing, but I got different answers. What probability that p hat is less than or equal to 0.65 is a normal CDF from negative 100 to 0.65. That's the same thing here. The 0.72 is the same, but the standard deviation is different. This one's smaller, meaning it's like this, so it's more difficult to get that far out into the shaded area. So look, if this basketball player takes 50 free throws, there's almost a 15% chance that they would shoot less than 65%. But if they start shooting 100 free throws, we're getting to a smaller probability area, and we're just about to the point where we can get less than 5% and start calling BS on this guy being a 72% free throw shooter. Why are the two answers different? Because of the different standard deviations. Bigger sample size means smaller standard deviation. You guys saw it when we picked quarters. You saw it when we did bop it. You saw it when you rolled dice. If you rolled more dice, you got a smaller standard deviation. If you took more bop it things, you got a smaller standard deviation. When you picked more quarters, you got a smaller standard deviation. Your homework for today is on page 430. You guys should do numbers 1, 2, 5, 6, 13, and 14. We're going out of the book today. I should post the answers. Have yourselves a good day. Larson out. X bar sampling distribution tomorrow, people.